Hello and welcome back at the Finite Link channel. Today we will go through the wireless LAN. So I'm pretty sure that you have seen wireless connection at home, work, or at school. But have you ever wondered yourself how it works? There are many ways to connect wirelessly. Like everything else involving networks, these connections types are best used in particular situations. They require specific devices and are also prone to certain types of attacks. And of course, there are solutions to mitigate these attacks. So we will go through these concepts, and here we will this material will give you the foundational knowledge you need to understand what wireless LANs are, what they can do, and how we need to protect them, which means that what we will learn in this material will be explaining how wireless LAN enable network connectivity, and the topics that will be included will be describing wireless LAN technology and standards, describing the components of wireless LAN infrastructure, explain how wireless technology enables wireless LAN operation, explain how a wireless controller use control and provision wireless access point to manage multiple access points. We will describe channel management in a wireless LAN. We will describe threats to wireless LAN. And then we will even describe wireless LAN security mechanisms. So in the first video, we will see only the first three topics. So let's go and see each of these first three topics by itself, starting with describing wireless LAN technology and standards. Wireless LAN is a type of wireless network that is commonly used in homes, offices, and campus environments. Network must support people who are on the move. People connect using computers, laptops, tablets, and smartphones. There are many different networks infrastructures that provide network access, such as wired LANs, service provider networks, and cell phone networks. But it's the wireless LAN that makes mobility possible within the home and business environment. In business, with a wireless infrastructure in place, there can be a cost saving anytime equipment change or when relocating an employee within a building, reorganizing equipment or lab, or moving to a temporary location or project site. A wireless infrastructure can adapt to rapidly changing needs and technologies. But wireless networks are based on the Institute of Electrical and Electronics Engineer standard and can be classified broadly into four main types. We have the wireless personal area network, which is called use low power transmitters for a short range network, usually to 20 to 30 feet or 6 to 9 meters. Bluetooth and Zigbee these devices are commonly used in wireless personal area network. Wireless personal area networks are based on the 802.15 standard and they have a 2.4 gigahertz radio frequency. We have even the wireless LAN. They use transmitters to cover a medium-sized network, usually up to 300 feet. Wireless LAN are suitable for use in a home, office, and even a campus environment. Wireless LAN are based on the 802.11 standard and they have a radio frequency of 2.4 GHz or 5 GHz. We have even wireless metropolitan area network. They use transmitters to provide wireless service over larger geographic area. Wireless metropolitan area networks are suitable for providing wireless access to a metropolitan city or a specific district. Wireless metropolitan area network use specified license frequency. And then we have even the wireless wide area networks. This kind of networks uses transmitters to provide coverage over an extensive geographic area. Wireless wide area networks are suitable for national and global communications. Wireless wide area networks also use specific license frequency. Wireless technology uses the unlicensed radio spectrum to send and receive data. The unlicensed spectrum is accessible to anyone who has a wireless router and wireless technology in the devices that they are using. Depending on that, we have this kind of technology. We have the Bluetooth. This standard use a device pairing process to communicate over distances up to 300 feet, which means 100 meters. It can be found in smart home devices, audio connections, automobiles, and other devices that require a short distance connection. And there are two types of Bluetooth radios. We have the Bluetooth Low Energy. They support multiple network technologies, including mesh topology to large-scale network devices, and Bluetooth Basic Rate or Enhanced Rate, which support point-to-point topologies, and it is optimized for audio streaming. We have even WiMAX, Worldwide Interoperability for Microwave Access, is an alternative to broadband wired internet connections, competing with DSL and cable. However, it is typically used in areas that are not yet connected to a DSL or cable provider. This standard provides high-speed wireless broadband access of up to 30 miles, around 50 kilometers, and operates in a similar way to Wi-Fi, but a higher speed over greater distances and for a greater number of users. It uses a network of WiMAX towers that are similar to cell phone towers, as you can see in the image. Their transmitters and cellular transmitters may share space on the same tower as it is shown here. Another kind of wireless technology is the cellular broadband. The cellular 4G, 5G are wireless mobile network primarily used by cellular phones, but can be used in automobiles, tablets, and laptops. Cellular networks are multi-access networks carrying both data and voice communications. A cell site is created by a cellular tower transmitting signals in a given area. Interconnecting cell sites from the cellular networks. The two types of cellular networks are global system for mobile and code division multiple access, where the global system for mobile is internationally recognized, and while the code division multiple access is primarily used in the USA. The fourth generation mobile network is the current mobile network. Fourth generation delivers speed that are 10 times the previous 3G network. The new 5G holds the promise of delivering 100 times faster speed than 4G and connecting more devices to the network than even before. And the last wireless technology is the satellite broadband, which provides network access to remote sites through the use of a directional satellite dish that is aligned with a specific geostationary Earth orbit satellite. It is usually more expensive and requires a clear line of sight. Typically, it is used by rural homeowners and business where cable and DSL are not available. And since we are talking about wireless and wireless technology, it is important to know in which standard the wireless technology works. So the world of wireless communication is vast. For particular job-related skills, we want to focus on specific aspects of Wi-Fi. The best place to start is with the 802.11 wireless LAN standards. These standards define how radio frequencies are used for wireless links. Most of the standards specify that wireless devices have one antenna to transmit and receive wireless signals on the specified radio frequency, which should be 2.4 gigahertz or 5 gigahertz. But some of the newer standards that transmit and receive at higher speed require access points and wireless clients to have multiple antennas using the multiple input and multiple output technology. This kind of technology, multiple input and multiple output, use multiple antennas as both the transmitter and receiver to improve communication performance. Up to 8 transmit and receive antennas can be used to increase the throughput. And since there are varying implementation to these standards that have been developed over the year, in this table is the most highlighted of these standards. We have the standards, in what kind of radio frequency they work, and the description for each of those standards. So all wireless devices operate in the radio wave range of the electromagnetic spectrum. Wireless LAN networks operate in 2.4 gigahertz frequency band and the 5 gigahertz band. Wireless LAN devices have transmitter and receivers tuned to specific frequencies of the radio wave range, as it is shown here in this figure. And here it is listed even the frequency bands allocated for 802.11 wireless LAN. There are wireless standard organization that ensure interoperability between devices that are made by different manufacturers. And internationally, there are 3 organizations influencing wireless LAN standards, and it's the International Telecommunication Union, which regulates the allocation of the radio frequency spectrum and satellite orbits through the International Union, and the ITUR stand for the International Telecommunication Union Radio Communication Sector. We have even the electric and electronic engineers which specify how radio frequency is modulated to carry information. It maintains the standards for local and metropolitan area networks. And the most dominant standard here is the family of Ethernet and wireless LAN. For Ethernet is 802.3 and wireless LAN is 802.11. And we even have the Wi-Fi Alliance, which is a global non-profit industry trade association devoted to promoting the growth and acceptance of wireless LAN. It is an association of vendors whose objective is to improve the interoperability of products that are based on 802.11 standard by certifying vendors for conformance to industry norms and otherness to the standards. So that is all the information about as an introduction to the wireless network. And now we will go through the components of the network. Wireless deployments require a minimum of 2 devices that have a radio transmitter and a radio receiver tuned to the same radio frequencies. And devices with a wireless network interface card or a network device such as a wireless router or a wireless access point. To communicate wirelessly, laptops, tablets, smartphones, or even the latest automobiles include integrated wireless network interface cards that incorporate a radio transmitter receiver. However, if a device does not have an integrated wireless network interface card, then a USB wireless adapter can be used as it is shown here in this figure. Remember, many wireless devices you are familiar with do not have visible antennas. They are embedded inside smartphones, laptops, and wireless home routers. The type of infrastructure device that an end device associate and authenticate with varies based on the size and requirement of the wireless LAN. For example, a home user typically interconnect wireless device using a small wireless router as it is shown here in the figure. And the wireless router serves as an access point that provides the wireless access for the standard 802.11 version A, B, G, and AC. He operates even as a switch by providing a 4-port full duplex for 10, 100, 1000 Ethernet switch to interconnect wired devices, and as a router where provides a default gateway for connecting to other network infrastructure such as internet. A wireless router is commonly implemented as a small business or residential wireless access device. The wireless router advertises its wireless services by sending beacons containing its shared service identifier SSID. Devices wirelessly discover the SSID, so the service set identifier, and attempt to associate and authenticate with it to access the local network and internet. Most wireless routers also provide advanced features such as high-speed access, support for video streaming, IPv6 addressing, quality of service configuration utilities, and USB port to connect printer or portable devices. Additionally, home users who want to extend their network service can implement Wi-Fi range extender. A device can connect wirelessly to the extender, which boosts its communication to be repeated to the wireless router. And while range extenders are easy to set up and configure, the best solution would be to install another wireless access point to provide dedicated wireless access to the user devices. Wireless clients use this wireless network interface card to discover nearby access point advertising their SSID. service set identifier. Clients that attempt to associate and authenticate with an access point. After being authenticated, wireless users have access to the network resources. Here in this figure, it is shown a Cisco Meraki Go access point. And there are two categories for the access point. We have the autonomous access point, and these are standalone devices configured using a command line interface or a GUI interface, graphic interface, as shown here in this figure. Autonomous access points are useful in situations where only a couple of access points are required in the organization. A home router is an example of an autonomous access point because the entire access point configuration resides on the device. If the wireless demand increased, more access points would be required. Each access point would operate independent of other access points, and each access point would require manual configuration and management. This would become overwhelming if many access points were needed. So we have even the other category of access point, which will be control-based access point. Here, the devices require no initial configuration and are often called lightweight access point. Lightweight access point use the lightweight access point protocol to communicate with the wireless LAN controller, as it is shown here in this figure. Control-based access points are useful in situations where many access points are required in the network. As more access points are added, each access point is automatically configured and managed by the wireless controller. As you can see here in this figure, the wireless controller has 4 ports connected to the switching infrastructure. These 4 ports are configured as a link aggregation group to bundle them together, much like how Ether channel operates. Link aggregation group provides redundancy and load balancing. All the ports on the switch that are connected to the wireless controller need to be trunked and configured with Ether channel on. However, link aggregation does not operate exactly like Ether channel. The wireless controller does not support port aggregation protocol or link aggregation protocol. And as the components of wireless network, the other component that is very important to know is about the wireless antennas, because most business class access points require external antennas to make them fully functioning units. We have omnidirectional antennas. These antennas, as it is shown here in this figure, provide 360-degree coverage and are ideal in houses, open office areas, conference room, and outside areas. We have directional antennas. They focus the radio signal in a given direction. This enhances the signal to and from the access point in the direction of the antenna is pointing. This provides a stronger signal strength in one direction and reduced signal strength in all other directions. Example of a directional Wi-Fi antennas include Yagi and parabolic dish antennas. And we have multiple input, multiple output antennas. We use multiple antennas to increase available bandwidth for the 802.11 wireless network standard. And as we mentioned, there are up to 8 transmit and receive antennas that can be used to increase the throughput of transmission. For the wireless LAN, we can say that can accommodate various network topologies. The 802.11 standard identifies two main wireless topology modes. We have the ad hoc mode, which is when two devices connect wirelessly in a peer-to-peer manner without using access point or wireless router. Examples include wireless client connecting directly to each other by using Bluetooth or Wi-Fi direct. Here the standard refers to an ad hoc network as an independent basic service set. We have the infrastructure mode. This is when wireless clients interconnect via a wireless router or access point, such as in wireless LANs. Access point can connect to the network infrastructure using the weird distribution system, such as Ethernet. And then we have even the topology tethering, where is a variation of the ad hoc topology is when a smartphone or a tablet with cellular data access is enabled to create a personal hotspot. This feature is sometimes referred to as a tethering. A hotspot is usually a temporary quick solution that enables a smartphone to provide the wireless service of a Wi-Fi router. Other devices can associate and authenticate with the smartphone to use the internet connections. And for the infrastructure mode, which defines the two topology building blocks, we have a basic service set who consists of a single access point interconnecting all associated wireless clients. Two basic service sets are shown here in this figure, and the circle depicts the coverage area of the basic service set, which is called the basic service set area. If a wireless client moves out of its basic service area, it can no longer directly communicate with other wireless clients within this area. The layer 2 MAC address of the access point is used to uniquely identify each basic service set, which is called the basic service set identifier. Therefore, the basic service set identifier is the formal name of the basic service set and is always associated with only one access point. And as for the extended service set, is when a single basic service set provides insufficient coverage and two or more basic service set area can be joined through a common distribution system into an extended service set. An extended service set is the union of two or more basic service area interconnected by a wired distribution system. Each extended service area is identified by a SSID, and each basic service set is identified by its basic SSID, service set identifier. Wireless clients in one basic service area can now communicate with the wireless client in other basic service area within the same extended service set. Roaming mobiles wireless clients may move from one basic service area to another within the same extended service set and seamlessly connect. The rectangle area here in the second figure depicts the coverage area within which members of an extended service set may communicate. This area, it is called extended service area. And since we are talking about the 802.11 standard, we have to know even the frame of this standard, the frame structure, as we learned about the frame structure for the Ethernet. By recalling that all layer 2 frames consist of header, payload, and frame check sequences section. Here it is listed the 802.11 frame format, and it is similar to Ethernet frame format, except that it contains more fields as it is shown here in the figure. All 802.11 wireless frame contains the following field. They have the frame control, which identifies the type of wireless frame and contains subfields for protocol version, frame type, address type, power management and security seconds, and the duration. This is typically used to indicate the remaining duration needed to receive the next frame transmission. From a wireless device, we have address 1, which is the MAC address of the access point, is the receiver address. Address 2 is the transmitter address, MAC address of the sender. And address 3 is the MAC address of the destination, which could be a wireless device or a wired device. And from the access point, for the address 1 will be the receiver address, will be the MAC address of the sender. At the address 2 will be the transmitter address, MAC address of the access point. At the address 3 will be the MAC address of the wireless destination. At the sequence control will contain information to control sequencing and fragmented frames. And at the address 4, this is usually missing because it is used only in ad hoc mode. For the payload, this contains the data that will be for transmission, and the last one will be frame check sequencing, which is used for layer 2 error control. As for the wireless LAN, we have to know that they are hub duplex for shared media configuration. Hub duplex means that only one client can transmit or receive at any given moment. Shared media means that wireless clients can all transmit and receive on the same radio channel. This creates a problem because a wireless client cannot hear while it is sending, which it makes it impossible to detect a collision. To resolve this problem, wireless LAN use carrier send multiple access with collision avoidance. This is a method to determine how and when to send data on the network. A wireless client does the following for sending the data in the network. First, they listen to the channel to see if it is idle, which means that it sends no other traffic is currently on the channel. The channel is also called the carrier. Then it will send a request to send messages for the access point to request dedicated access to the network. We'll receive a clear to send message from the access point granting access to send. And if the wireless client does not receive a clear to send message, it waits a random amount of time before restarting the process. After it receives the clear to send, it transmits the data. All transmissions are acknowledged, and if a wireless client does not receive an acknowledgement, it assumes a collision occurred and restarts the progress. For the wireless device to communicate over the network, they must first associate with an access point or wireless router. An important part of the 802.11 process is discovering a wireless LAN and subsequently connecting to it. Wireless devices complete the following three stages that are shown here for connecting with the access point. First, they discover a wireless access point. Then they authenticate with the access point. And the last step is to associate with an access point. In order to have a successful association, a wireless client and an access point must agree on a specific parameters. Parameters must then be configured on the access point and subsequently on the client to enable the negotiation of a successful association. This will be the SSID, which is the name that appears in the list of available wireless network on a client. In larger organizations that use multiple VLANs to segment traffic, each SSID is mapped on one VLAN. Depending on the network configuration, several access points on a network can share a common SSID. The other thing that they need to share together is the password. This is required for the wireless client to authenticate to the access point. And then it is important to share even the network node. This refers to 802.11 wireless LAN standards. Access point and wireless router can operate in a mixed mode, meaning they can simultaneously support clients connecting via multiple standards. It is important to share even the security mode, which refer to the security parameter settings, and they will always enable to the highest security level supported. It is important to know and share even the channel setting, and this refers to the frequency band used to transmit wireless data. Wireless router and access point can scan the radio frequency channels and automatically select an appropriate channel setting. The channel can also be set manually if there is interference with another access point or wireless device. The wireless devices must discover and connect to an access point or wireless router. Wireless clients connect to the access point using a scanning process, but this process can be passive or active. How we will understand the passive and active mode of the process for connecting to the access point. The passive mode is when the access point openly advertises its service by periodically sending broadcast beacon frames containing the SSID, supported standard, and security setting. The primary purpose of the beacon is to allow wireless client to learn which network and access points are available in the given area. And with this, will allow the wireless client to choose which network and access point to use. And the inactive mode, wireless client must know the name of the SSID. The wireless client initiates the process by broadcasting a probe request frame on multiple channels. This probe request includes the SSID name and the standard supported. Access point configured with the SSID will send a probe request that includes the SSID, supported standard, and security setting. Activate mode may be required if an access point or wireless router is configured to not broadcast beacon frames. A wireless client could also send a probe request without the SSID number to discover nearby wireless LAN network. Access point configured to broadcast beacon frames would respond to the wireless client with a probe response and provide the SSID name. Access point with the broadcast SSID feature disabled to not respond. And this is all about the first three topics about the wireless LAN, and then we will go with topics that are left in the second video. Till then, do not forget to subscribe at this channel if you are new, and hit the notification button for the new videos that will be uploaded. If you like the video, share it with your friends. See you to the next session.